Hi everyone. In this lecture, we are going to have a first look at control systems. So we will see indeed the main structure of a control system. We will start by checking out the block diagrams or block diagram systems, as we are going to use them extensively in this course. And over here you can see the basic definitions that we have. So we have these elements. Let me just pick up the highlighter. We are going to deal with signals, which will be shown in the form of a directed arrow with the name of the signal written on that. We will have the systems, which will be shown in the form of a box, usually in the form of a rectangle, with the name of the system written inside. Indeed, G of S, which is written here, in most cases is in the form of a transfer function with some polynomial as the numerator and some polynomial as the denominator. We will talk about this later, but for now, just keep in mind that GS would be a transfer function. And then we will have some summing points. You can also see it here. So this will be indeed the summing point. And as the name suggests, the summing point will be the point in which a given number of the signals arrive, and then they are added to each other or subtracted from each other. And as a result, we will have another signal. So C of S here is the output that we get from the summing point. And you can see that we have it equal to R1 plus R2 minus R3. So again, keep in mind that the signals which arrive here could indeed get plus or minus signs with them. The summing point is also referred to as summing junction. Okay, so summing point or summing junction is indeed one of the main elements of the block diagram systems. And the next one is called the branch point. You can see the branch point over here. So let's say that we have a point here. We call it branch point or pickoff point. And you can see what happens over here, yeah, if you look at the graphics here. So RS is the original signal. And you can see that at any of the branches which are taken from that branch point, the signals are exactly the same. So it's a point from which the signal from a block goes concurrently to other blocks or summing points. Indeed, we can say that these signals RS could be the input to a given block, or they could be an input to a summing point, for example, with a given sign. So these are indeed the main components that we have for a block diagram systems. Again, the signals, systems, summing points, and branch points. We will use GS inside, you can see that it's written here, inside a block to represent a system. Okay, and again, the system could be represented in the form of a transfer function. And you should already be familiar with the transfer functions concept. Having said so, we can also combine the blocks which are connected to each other either in the form of a series or parallel connections. When we have them in the form of series, so when the blocks are connected in series with each other, the whole system could be replaced by a single block indeed. So over here you can see that these three blocks could be combined with each other, and we end up with a single block, as you can see here. And the transfer function that we get for this block will be the product of the all transfer functions that we had. So if you call this g of s, it will be equal to g1 times g2 times g3 of s. So, and it should be obvious, I think, because if you pay attention here to the signals that we had at the output of each block, you could get the idea. Over here we have the signal will be equal to g1 times r, which is the input to the second block, and therefore the output from the second block, I write it here, it will be equal to g2 times g1 times r, and the output from the third block will be equal to g3 times g2 times g1 times r. And therefore we can say that the output of the whole system here will be equal to g3 times g2 times g1 times r of s, and therefore the single block representing these three blocks in series with each other will have the transfer function equal to g3 g2 g1 of s. On the other hand, when we have the blocks combined with each other in the parallel form, and you can see one example over here, we can combine them indeed and represent them with a single block. The transfer function for that single block will be the summation of the transfer functions of all those single blocks. Over here you can see that first of all of the three blocks with the transfer functions g1, g2 and g3 are receiving the same signal. That's why we can say that they are parallel with each other, and their output are also being added at the summing point. If you follow the signals, you can see that r is provided as the input, so the output from the first block is equal to r times g1. For the second one we have r times g2, and for the third one we have r times g3, and therefore the final output c of s that we have will be equal to plus minus, depending on the sign, plus minus g1 plus minus g2 plus minus g3 r of s. And therefore if we replace the whole thing here with a single block, the transfer function for that will be equal to plus minus g1 plus minus g2 plus minus g3 of s. So in this way we can combine the blocks which are in parallel with each other.